Hi everyone. Let's do a conjecture about the y-intercept of the tangent to the curve at the point when x is equal to a. So we have here this beautiful graph. So this is on the next page. So we do have graph with the function. So the function to consider is f of x equal to f of x is equal to x over x plus 1, where x can't be equal to negative 1. So it can't be equal to negative 1. It's not going to be defined. So it's going to be, the asymptote. And the graph of y equal f of x is shown below. So here's the graph. The first part of the question is going to be to draw the tangent to the curve at the point when x is equal to 1. So x is equal to 1, and we're going to draw the tangent. Draw tangent. I'm just going to draw the tangent. Tangent to the curve. Okay. So, and 2 here is 1. So pretty much when x is equal to 1, so we're going to have straight line, tangent. So the tangent to the curve when x is equal to 1. So that's the first step to do it. Because we're going to deal with, some equations of the tangents to the curve and etc. So I can see that, I'm going to need the first derivative of this function. In the questions that have been emailed to you, you do have first derivative, so it's given. But anyway, I'm just going to find it. So this is original function here. To find the first derivative, we're going to use quotient rule because we have fractions, so we're going to use quotient rule. And my first part, this is going to be my u function, and this is going to be my v function. Using the quotient rule, f dash of x is equal to. So denominator is going to be x plus 1, everything to the power of 2. Numerator is going to be u dash, which is derivative of, so u is x, u dash is 1. V is x plus 1, v dash is equal to 1. So substitute, u dash is 1 times v, it's x plus 1, take away u, which is x, and times v dash, it's times 1. Rearrange a little bit, so it's going to be x plus 1, take away x over x plus 1 to the power of 2, which is going to give us, this is gone, 1 over x plus 1 to the power of 2. So this is the first derivative of f of x. So now we can say, yep, it's given is calculated. So is actually show that the equation of the tangent to the curve at the point where x is equal to 1 is this. So this part here. So it's x take away 4y equal to negative 1. So we have to show that the equation of the tangent to the curve when x is equal to 1 is equal to this equation here, and find y-intercept of this equation is equal to x take away 4y and equal to negative 1. So we do need to find the equation of the tangent. We have seen it before. To find the equation of tangent, we are looking for point of contact. So, and x is given, so x is equal to 1. When x is equal to 1, f of 1 is equal to, so I'm just going to write here original function, so it's x plus 1. When x is equal to 1, f of 1 is equal to 1 over 1 plus 1 and is equal to half. So we do have point of contact. So the point of contact is, just gonna point of contact is there. Okay, point of contact is 1 for x coordinate and half for y coordinate. So the next thing that we do need, so we do have the point of contact, so we do need to find what the slope is equal to when x is equal to 1. So x equal to 1, f dash of 1 is equal to 1 over 1 plus 1 to the power of 2 and is equal to 1/4. Please note that the first derivative is on the previous page. So now we do have the point of contact. So point of contact is there. We do have the first derivative. So the tangent when x is equal to 1 is equal to 1/4. So let's find this equation of tangent, or show that is equal to the one given. So what I'm going to do next is just using the slope equation, which is y take away y1, x take away x1, and equal to m. So different ways of doing it. I'm just going to go with this one now. So y take away y coordinate is half, that's the point of contact, and x take away 1 and is equal to m, slope is 1/4. So all this is when x is equal to 1. Rearrange, so my favorite one is just cross multiplication. So cross multiply. So we're going to have x take away 1 times 1, so I'm not going to write that, equal to 4 times y take away half. So expand it, play with it a little bit. 4 times negative half, which is going to be 2. So rearrange, so we can see like we're almost there. I'm going to move 4y to this side, and because it's positive on this side, it's going to become negative on the other side, and negative 1 is going to be shifted to the opposite side, so collecting like terms. So now we're going to have negative 2 here. Okay, I'm just going to have negative 2 and plus 1. So it's going to simplify into x take away 4y equal to negative 1. So what we have here, we have shown that the equation of the tangent to the curve when x is equal to 1 is equal to x take away 4y equal to negative 1. So the first part is done. Now, the next thing we're going to do is find the y-intercept of this tangent, of this one, okay? This tangent, y-intercept. How do we find y-intercept? So when x is equal to 0, pretty much it means instead of x, we're going to have 0. So 0 take away 4y equal to negative 1. So therefore, divide everything by negative 4. It's going to give us y is equal to 1/4. So y-intercept is 0 and 1/4. 0 and 1/4. Beautiful. Done. Let's go next. First, we had to show that the equation of tangent is equal to this when x is equal to 1. So it does look like that we do need to find an equation. Let's see what we have next. So what we have, the equation of the tangent to the curve at the point where x is equal to and x is equal to 3 are given. So what we have now here, x equal to 1, this one here, we have actually shown that when x is equal to 1, equation of the tangent is going to be this. X equal to 2, we didn't calculate, but they are giving us that it's equal to this part. X equal to 3, equation of tangent is equal to that. We have to find y-intercept of tangent. So y-intercept, so we already know for this one, x is 0 and y is going to be 1/4, or it is, we already calculated. About this one here, y-intercept, it's 0. So we're going to have 0 here, so it's going to be negative 9y equal negative 4. To get rid of negative 9, you divide both sides by negative, like divide here, negative 9, like that. So it's going to be 4/9. And same here, similar, x is equal to 0, so it's going to go. and then divide by negative 16, divide negative 16, so it's going to give us 9 over 16. So now this is like, to make a conjecture about the y-intercept of this tangent to the curve when x is equal to a, so which means for any values of x. So we're just gonna have a look here what's happening, and we're gonna look for some patterns. So they all have x coordinate is 0, which is fine. Let's have a look at y-intercept. So we can see that he's 1, okay, so it doesn't give me enough information, so that's like sort of 1, yeah, over 4. It does look like 2 to the power of 2, okay. Now let's go to the next one. I have 4. 4 can be written as 2 to the power of 2, and then 9 is 3 to the power of 2, okay. Next one, 9 over 16, is like 3 to the power of 2 over 4 to the power of 2. And I can see actually there is like sort of pattern. So it does look like this is to the power of 2 as well. And it sort of gives me that this number here, 1, 2, and 3, represent the x coordinate. So based on this, it does look like, x to the power of something. And denominator, I have 2, which is x equal to 1 increased by 1. I have 3, x equal to 2 increased by 1. And then we have 4 is like x plus. So I'm just going to rewrite this. Like, it looks like this. 1 plus 1 to the power of 2 equal to 2 to the power of 2 over 2 plus 1 to the power of 2. And then this one here is 3 to the power of 2, 3 plus 1 to the power of 2. So there's a pattern. So now we can make conjecture. So the y-intercept of the tangent to this curve when x is equal to a, so when x is equal to a, x is any number, it does look like a to the power of 2 over a plus 1, a is any number, brackets, and everything to the power of 2. So 0, x coordinate, and y coordinate. Okay, so this is our conjecture. The next thing we're gonna on next page, prove or disprove the conjecture. So what has been given? X is equal to a. We set the point of contact when x is equal to y-intercept. So when x is equal to 0, we're looking for the y-intercept, a to the power of 2 and a plus 1 and everything to the power of 2. Okay, now let's move to proving. Let's prove it. Now, prove or disprove the conjecture. So pretty much what we're going to do, we're going to go a few steps back and see what is actually to prove or disprove this conjecture. So I'm just going to write here on the side what our conjecture is. When x is equal to a, we're talking about y-intercept. So x is 0 and y-intercept is going to be a to the power of 2, a plus 1 and everything to the power of 2, the brackets. This is what we have to prove. As we have done before, so we're looking for the equation of the tangent. So and then when x is equal any number, in this case as x is equal to a, y-intercept needs to be equal to that. So let's start. So the first thing is point of contact. So point of contact. So, and that's when x is equal to a, f of a is equal to, let's just put it on the side, f of x is equal to, let me just find, I think is f of x is plus 1. So therefore f of a is a over a plus 1, and f dash of x is equal to f dash of x is equal to x plus 1, everything to the power of 2, and we're gonna have 1 in numerator. So we do have the point of contact, so this is a and a over a plus 1. So let's go like y take away y1, which is this value, over x take away a, and is equal to, so y dash f dash of x when x is equal to a, so it's going to be f dash of a is 1 over a plus 1 to the power of 2, so it is equal 1 over a plus 1 to the power of 2. Same as we have done before, cross multiplication. So cross multiplication. Now this is gonna give us x take away a equal to a plus 1 to the power of 2 times y take away a over a plus 1. So expand, so x take away a is equal to, so a plus 1 to the power of 2 times y, and take away a plus 1 to the power of 2 times a plus 1. Next step we're gonna do is to see if we can simplify anything, so we can cross out this one and this one. So this is gonna give us, if I expand this part multiplying a, it's gonna give us negative a to the power of 2 and then take away a. Before we move on to the next line, we do have a's, negative a's on both sides, so we can cancel out this. So, and then x is equal to a plus 1 to the power of 2y, take away a to the power of 2. Now, we have to prove the conjecture, which is when x is equal to 0, that y is equal to this part here, so that y is equal to this. Let's say x is equal to 0. X is equal to 0, so it's going to be 0 equal to a plus 1 to the power of 2y, take away a to the power of 2. So from here, so move this part to the other side, so it will become positive a to the power of 2 is equal to a plus 1 to the power of 2 times y. And now we're gonna get rid of this part by dividing both sides by the same thing, which is a plus 1 to the power of 2. And now this is gone, so therefore y is equal to a to the power of 2 over a plus 1 to the power of 2. And we can see that our y-intercept when x is equal to 0, it is exactly the same as our conjecture. So therefore, proved. Thank you. See you next time. Bye.